Hey everybody, it's Mr. N here, and the lesson for today is just on some 3D figures, a few names that we got to know, and some that you probably already know. So let's get started with this. First of all, we have types of solids. We have polyhedra right here, and we've got ones that are not polyhedra. And a prism would be considered a polyhedra. Cylinders and cones and spheres, these are not polyhedra, and a pyramid is a polyhedra. Now, do you notice the difference between the two? Well, basically, polyhedra won't have any of these curved surfaces. So, prism is a polyhedron possessing two congruent polygonal faces with all remaining faces as parallelograms. So this is a prism as long as it's got two congruent polygonal faces. So let's continue on. You can look up some examples of other prisms from these websites right here. This is a good one. It just shows them three-dimensional and it kind of rotates them so you can see all sides. Over here, some terminology. We've got the base of the prism that we're talking about. So it's got two bases. The bottom right down here, I'll shade it for you. Let's go ahead and shade it like a reddish color. And then the top right here as well. Those are both the bases, so the top and the bottom. Then you've got a lateral edge right here. So this edge, and I'll do that in another color, right there is a lateral edge. That's a lateral edge. The one back here is a lateral edge. And then you've got faces. This is the face right here. You can also say it's a lateral face. On the side back here, let me see if I can change the pointer a little bit. So that is also back here a face. The front is a face, and the one on the back side over there. So we always name a prism according to its base. So if the base looks like a triangle, such as this one, we will call this a triangular prism. Now this is slanted, so this is oblique. So whenever you see a slant on it like that, it's going to be oblique. Here's a rectangular prism because the base is in the shape of a rectangle. Now this is a rectangular right prism, not because these are right angles in here, but because this right here, it's not slanted. Here's a pentagonal prism. This is oblique because it's slanted. And here's a hexagonal prism. This is a triangular pyramid, rectangular pyramid, pentagonal pyramid, and a hexagonal pyramid. So a pyramid will come up to a point at the top, different than a prism. So a pyramid has this point at the top, and we're going to get into these a little bit more soon. Terms that we always need to know: you need to know what a base is, you need to know what a lateral edge is. We talked about what lateral faces are, and then you need to know if it's the altitude, if it's a right angle like this one, or if it's slanted. If it's slanted, we're going to call it oblique, and if it's a right angle, we'll say that it's a right prism, right pyramid, that type of terminology. So moving on, let's take a look. Here's the terminology again of each of these. So we've got a prism, and we're going to go over these. Again, we're going to cover each of these in more detail as time goes on, but here they are now. I'm just introducing them to you. So we know what a prism is. Two parallel congruent polygonal faces, so the top and the bottom need to be the same. Then we've got a cylinder, and on a cylinder you've got these circular bases, but they don't necessarily have to be circular. I'll get into some details about this later, but the only ones we're going to deal with are circular bases. But for the sake of knowing what a cylinder definition is, I'll tell you a little bit more later. Pyramid, we said it's going to have this vertex, this apex right here at the top where the faces all meet. And then a cone used to have the same type of vertex. So again, we're going to get into more of this terminology later, but these are shapes you should already be familiar with. Next, we have this net right here. A net is a diagram of the surfaces of a three-dimensional figure that can be folded to form the three-dimensional figure. To identify a three-dimensional figure from its net, look at the number of faces and the shape of each face. So basically, when we unfold the three-dimensional figure, and that's how you got to think of it is, unfold it, and what it looks like will be that net that we end up with. Okay, so in this case, this is going to form a cube. If we take a cube, unfold it, this is what you get. A cross section is, suppose I take a slice of this. In this case, I take a plane and I'm just going to slice it now. I could slice it diagonally. I could slice it horizontal. It doesn't matter how I slice it, but this slice is going to create what we call a cross section. So moving on, here are different types of cross sections. If I take this cross section in this manner, I form a square. If I take a cross section of this cube diagonally like that, I form a rectangle. If I take a cross section in this method, I will get a triangle. So depending on how I take my slice, that's the shape I'm going to get. And then here's something that's interesting. A solid of revolution is a three-dimensional figure that is formed by rotating a two-dimensional shape around an axis. So I take this two-dimensional shape and I rotate it. So if I rotate it around, I'll get a cylinder. So this is my axis of rotation, or you can call it the axis of revolution. This is something you're going to be doing if those of you that move on in math and get to calculus, you'll be doing a lot of these. All right, so that's pretty much it. It's the basics today. We're going to get into all the shapes as time goes on, but I want you to turn to, open up those student journals of yours, and we're going to do the problems on page 332. We're going to do numbers 1 through 8. Okay, so getting into these, it says, I wanted to tell whether the solid is a polyhedron. Yes, this first one, this is a polyhedron. Oops, let's change the color here. Yes, it is a polyhedron, and in this case, it's an octahedron. Okay, over here, this is not a polyhedron. These are curved surfaces. All right, let's move on to the next questions. Over here, it says describe the cross-section formed. This looks like a rectangle, so we're going to say a rectangle. If these are the same size, and it indicated that it's a square base, then we could say it's a square, but it didn't, so we're going to just say that it's a rectangle. This cross-section right here is going to be a triangle. And this cross-section will look like a trapezoid. This cross-section, let's count the sides. We've got 1, 2, 3, 4, 5, 6, 7 sides. So it's a heptagon. Remember, hepta is 7 sides. All right, let's see what else we got going on here. It says in 7 and 8, sketch a solid produced by rotating the figure around the given axis and describe the solid. So if I were to rotate this around, it would look something like that. And this would be called a truncated cylinder. So the top and the bottom is some sort of like vase type looking object. Okay, over here, if I were to rotate this around and this part, it would almost look like, let me draw it a little bit better. A little more. Over here, this part will be circular down here. So this will end up being circular, same with this, and the top will go like this. So you'll end up with something that looks more like, and if I kind of erase so you could see the three-dimensional part a little bit better, it'll look like that. And that's maybe like a circus tent. So you've got this going around right there, and then the tent part of it up here. So this and this. I don't know if that looks like it to you, but that's what it would be. So anyway, hopefully these weren't too bad. We're going to get into each specific solid, finding volumes and surface area in the next few lessons. But right now we're just identifying the solids and what parts of them and what happens when we take cross sections and certain names. So thanks for watching this. Hit the like and subscribe button, and I'll see you in the next video.